One of the nice things about IPv6 is that it supports auto configuration of IP addresses automatically. So the need for DHCP is sort of obviated by the protocol itself. But there is, in certain circumstances, where it does make sense to use DHCP with IPv6. So let's just talk about the process here. So IPv6, DHCPv6 in Windows allows you to manage IPv6 addresses. You can see which addresses are being used on the network. So just like you can with IPv4 in the user interface. And you can control the IPv6 address options as well. So an IPv6 address is not all that different from a IPv4. It's just much longer, and it can be comprised of an interface ID, which is essentially the MAC address of the machine. So you can kind of get a sense for how it's easier to generate unique IP addresses from IPv6 as opposed to IPv4. So they're usually written as 8 16-bit hexadecimal numbers separated by colons. So this is an example of what an IPv6 address might look like. Some things to note here is that if you have more than one consecutive zero values, you can represent them with a single double colon, but you can only do that once in the address. So if you ever see the double colon, it's because there's multiple consecutive zeros. Leading zeros are optional. And the reason we use hexadecimal numbers is because it's much easier to convert those to binary than it is to convert decimal numbers to binary. One of the pain points for a lot of students when they take a networking class is, I have to learn how to convert binary. But it's a little easier to do that with hexadecimal digits. For example, F is all ones and 0 is all zeros. And it's pretty easy to figure that out for the remaining digits. So the interface ID of an IPv6 is typically 64 bits, and it's going to use the interface's 48-bit MAC address for most of that address, as well as a 16-bit value of FFFE that's inserted after the first 24 bits. So basically the first 24 bits of the MAC address, and then the remaining is FFFE to fill out the remaining 64 bits. So if you do that, it's pretty reasonable to assume that you're going to get a fairly unique IP address just from that alone. So the first two zeros in a MAC address are replaced with 02, and this is auto-configured. The auto-configured 64-bit host ID is referred to as the Extended Unique Identifier, or EUI 64-bit interface ID. So IPv6 address is entered manually in the interface's property dialog box. And there's other ways that an IPv6 interface ID can be assigned. You can use a temporary interface identifier, which is what happens when you connect, for example, through a VPN and are assigned an IPv6 address through a VPN. It's going to get assigned, so it may not necessarily use a MAC address in that case, or via DHCPv6, which is the other method. So it can be auto-configured in the steps we just described in the previous slide. It can be configured through whatever node is assigning the IP address through a VPN or through PPP connections or dial-up, and then via DHCPv6 as an alternative. All right, so basically a unicast address specifies a single interface on a device. So a unicast address in IPv6 is basically that node's IP address in IPv6, and there's three types. You have a link local, a unique local, and global. Link local is basically a unique IP address that's known to be unique within that network, and it's for computer-to-computer communication, so it's not routable. So a link local address is not routable outside your local area network, so it won't make it past a router. A unique local address is it's addresses that start with FC or FD, and they're for use behind a firewall, and they are pre-configured on routers. So unique local is sort of like a local private IP address, more or less. And then a global is basically an IPv6 address that is routable from the internet. So it would be accessible from the internet if your firewalls are configured to do so. So those are the three types of IPv6 addresses that we could use. So auto-configuration occurs by one of two methods, either through stateless auto-configuration, where the node listens for router advertisement messages from a local router, and it uses that to configure its IPv6 settings. It could be through stateful auto-configuration, where the node uses an auto-configuration protocol such as DHCPv6 to obtain its IPv6 address and other configuration information. So in other words, in the first option, it's listening for advertisement messages from a router to tell it how to configure itself, and it auto-configures its own address. So in that sense, it's sort of self-managed. Or through stateful auto-configuration, which is more similar to what we learned about in DHCP for IPv4 addresses. So it works in roughly the same way. So how auto-configure works on Windows hosts. So the Windows auto-configuration steps are as follows. At initialization, it's going to get a link local address, which, as you recall, is for computer to computer only. It's not routable. Then the link local address is verified as unique by using duplicate address detection. If the address is verified as unique, the address is assigned to the interface. If the host transmits a router solicitation message, that's step number 4. So it's basically looking for the information on how to communicate with a router. If no router advertisement messages are received, then it's going to fall back to DHCPv6. In other words, if the router doesn't say here's how to reach the router so it can route traffic and get out of its local area network, then it's going to try to use DHCPv6 to try to do that. If the router advertisement is received, the prefix in the router advertisement is used along with the interface ID to configure the IPv6 address on the interface. So again, it can either be configured with DHCP6 or auto-configured from the router solicitation message. So to create a scope in DHCPv6, you can do that with the PowerShell commandlet. You'll need to provide the scope name, the prefix, preference, and exclusions, as well as the scope lease time. So this is really not all that different from setting up a scope in IPv4 DHCP. So DHCP6 uses a DHCP unique identifier to lease an address. It's a hexadecimal number. It's usually derived from the MAC address, as we discussed before. After a DHCP6 scope is created and activated, the server can assign IPv6 addresses. So the dynamic assignment of IPv6 addresses is very similar to IPv4, except it's going to use different port numbers. So it's going to use port 547 on the server side, and the client's going to listen on port 546 for the response. All right, so you're going to configure for DHCP options. You can configure DHCPv6 options just as you do for DHCPv4. There's no option to assign a default gateway. The task is handled by router advertisements sent by routers on the network. You can configure options at the server level, the scope level, and the reservation level. Not all that different from IPv4. In the next slide deck, I'm going to cover high availability with DHCP.